Hey guys, how you doing? This is Coach Scott. We're diving right into our study of chemical reactions. Let's talk about double replacement, otherwise known as double displacement reactions. Get the stupid thing to change. There we go. So there's two types of double replacement reactions. You can also call them double displacement, whatever. So in an acid-base reaction, especially between a strong acid and a strong base, one of the products is always water. And we're going to study these reactions in our next topic. In another type of double replacement reaction, it's a precipitation reaction. And one of the products is a solid precipitate that falls out of solution. Now, this reaction will only proceed if one of the products is insoluble, which means you can't dissolve it in water. If both are soluble, the products will dissolve as quickly as they form, so no reaction will proceed. So, precipitation reactions involve the reactions of a water-soluble ionic compound or water-soluble ionic compounds to form a water-insoluble product called a precipitate. So then we have two clear compounds here, silver nitrate and hydrochloric acid, aqueous. And when we mix them together, a silver chloride solution will fall out of solution. Notice it's a solid, and the nitric acid is aqueous, so you still have those anions of those ions in solution. But you notice you have a cloudy precipitate of silver chloride. So these reactions has a unique skeleton, right? The reactants are two compounds, and the products are two different compounds with the combination of elements changed as below. AB plus CD yields AD, they'll flip-flop, plus BC. Now these are also, like I said earlier, called double displacement reactions. So what happens, we have sodium chloride and silver nitrate. The nitrate, will replace the chlorine, and the sodium, the sodium and the chlorine bond breaks, all right, and the sodium will bind with the NO3. And then the bond between the silver nitrate breaks, and the silver and chlorine will form a bond. Now, a precipitation will not occur if both products are water soluble. Those ions will still be in solution. If they're soluble, no reaction will occur. So, some ionic compounds are water soluble, some are not. The insoluble compounds will form a precipitate. Now, there's big charts, detailed charts of solubility, but we're going to follow the College Board's approach for the AP exam. And for the AP exam, you're only expected to know that all sodium, Na, potassium, K, ammonium, NH4+, and nitrate salts are soluble in water, while other elements and compounds are not. Now, a salt is an ionic compound consisting of a specific number of anions and cations in each formula unit, and it has a net neutral charge. So, easy way to remember it, there's two ways. You can go NaCN, sodium, potassium, ammonium, nitrate, or I like SNAP, sodium, nitrate, ammonium, and potassium. Whatever floats your boat. Okay, so these are some examples of soluble salts: sodium chloride, sodium fluoride, sodium sulfate, potassium chloride, potassium carbonate, ammonium carbonate, ammonium chloride, ammonium nitrate, then of course potassium nitrate, ammonium nitrate, and sodium nitrate. So yeah, those are always soluble in water. So here's some examples of some precipitation reactions. I've got lead nitrate plus 2 moles of potassium iodide. I'm forming lead iodide and potassium nitrate. Using our SNAP rules, potassium nitrate is not insoluble, or is very soluble, so it's going to stay in solution. Lead iodide is not one of the SNAPs, not one of the NaCNs, so lead iodide is not soluble. It's going to be insoluble. It falls out of solution. Silver nitrate is soluble. Potassium chloride is soluble. But silver chloride is not soluble. It's going to fall out of solution, leaving potassium nitrate ions. So we're going to go into details of why these reactions happen later. But note, in both of the reactions above, the chemical bonds break and reform to produce solid products. So let's work on some stuff. Predict the products of this reaction. Potassium phosphate plus magnesium chloride. So first I've got to write a formula. So that's K3PO4 plus magnesium chloride. Okay, that's not equal sign, should be 4, but anyway, my fault. Yeah. And so now we wrote a formula. So now we have to predict the products. So potassium is going to replace the magnesium, and then the phosphate and the chlorine will still be there. So after we've got our formula drawn, KCl plus magnesium phosphate, now we've got to use our the phases. So that's aqueous. Potassium chloride, well, that's going to be soluble because of the SNAP rules, NaCN, and that's insoluble. That's going to be soluble. Magnesium phosphate is soluble, so that's going to be insoluble. So that's going to be an S. That's going to be an AQ. So will this reaction proceed? Yes, yes it will, because we have a precipitate coming out. Let's try this one. Calcium fluoride plus sodium sulfate. We've got calcium fluoride, it's in an aqueous solution, and sodium sulfate. So predict the products, replace the two cations. All right, so that would form a sodium fluoride plus calcium sulfate. Notice that it's not balanced yet, but now we've got to put the right phases in and balance the reaction. So we do, and we see that sodium fluoride is aqueous because it's soluble, SNAP rules, NaCN, and calcium sulfate is insoluble. So it will precipitate out, it'll be a solid. So will the reaction proceed? Yes, yes it will, because one of the products is a precipitate. Okay guys, so that's a double displacement precipitation reaction, and those are sort of cool. We'll play with some of these in class, and you'll get to see these. So anyway, this is Coach Scott saying bye for now. Have a great day and be good.